Alright, boys. We're going to use this whiteboard here. You beginner detectorist. You need to watch this video. You might find my channel. A friend may show you where it is, you know. I'm not begging for subscribers. I show data. Okay. See that black line up there? That's going to sort of indicate our coil. You're going to see machines like the Nocta Legend, Equinox, Manicore, Deus 2, Deus 1. Have fast and slower speed settings on them. Up here at the shallow depth, we can go and put those machines in ultra fast speed settings. We can line up coins and nails and just sweep and just hear the music played with the audio on them machines. Is that going to get you where you need to be in the wild with those models detectors? The answer is no. Not in all applications. Number one, you're depth limited. The audio gets weaker as the target gets deeper. Running it faster, the audio will get weaker till it disappears. Okay, so to get the depth, you need to run the machine slower. Alright? Now, see how big that coil is. So it's coming across the ground. Well, when the detector is run slower, these coil edges, for lack of a better expression, are hotter. When the machines run faster, the perimeter of the coils are more detuned. Okay, that's why when you do that fast setting with the coins laying on top of the ground like they did over there at Detectorist with the Equinox, that's why the machine behaves like it does. The center of the coil is hot. That's why in iron sights you could have nails like so, and you might hear a target in the middle, even with a faster sweep speed. Sweep speed is a factor. Okay, so now the target gets deeper. Alright, that little circle there is like a target. You've got a masker over here. Alright, you've got a low conductive masker. Without that low conductive masker, this may not be out of range necessarily depth-wise for a faster speed setting. However, without notch, you would hear both targets and you would get maybe a commingled ID. So you don't know what you've got down there if you're select digging. So let's say you're trying to notch. Let's say this is a silver dime right here. Say that's a silver dime. You're running the machine slower. You use notch. Well, what's going to happen is slower speed. Remember what I said about the coil perimeter being hotter. So as the coil is slipped back and forth, the edge of that coil, depending on the orientation, is going to trail behind the modern trash. So if we move this coil up here in this direction, like I'm moving that marker, this part of this coil right here is going to come past the low conductive masker, and it's going to get over here, and there's enough strength left in that coil to say boom, and it's going to come over your notch. You won't hear this target here, the low conductive masker. Now the conductivity of this low conductive masker is a driver, and so is its size. Okay? Running a machine faster in this scenario right here, even with a notch, the coil perimeter is detuned. So when you sweep the coil as such and you get out over here in this area above this fine, you know, the coil is up here, but the coil vertically it's over here. There's nothing there for the detector to see. It won't see it. Won't alert you. Okay? Okay, camera back on. Now, different modes on these machines can use different frequency. Okay, Manicore, the Equinox, the Legend. They can use different frequency weighting. It doesn't really matter what you want to call it. The effect is the target scenario can behave different. For example, there's a gentleman on Friendly Forum. He's evidently just got into detecting. He's got a Vanquish machine. He's out looking for his grandfather's lost ring years ago. Okay, and he said he's been out looking for it using the jewelry program. Well, could he find that ring using the coin program on that detector? I've not owned a Vanquish. I suspect that the coin program is running higher frequency or lower frequency versus the jewelry program, which would run higher frequency, sort of like part 2 versus part 1. Part 1 running lower frequency on an Equinox 800. Okay, or deep high conductor versus fast program on a DS2. So the frequency you use is going to drive your performance in these masking situations. Okay? But lower frequency can struggle around iron. Higher frequency can struggle around trying to differentiate a lower and a higher conductor depending. Okay, now some models, like the DS2, offers a 24 max frequency setting. Okay, the Manicore, for example, all-terrain general sits in between all-terrain low conductors and all-terrain high conductors. So you sort of get the best of both worlds. You get good lower conductive trash unmasking on higher conductors, and you get good performance around iron. Unlike the deep high conductor, say on the DS2 running 14 max, and the all-terrain high conductor on the Manicore. See, it's always a trade-off. No matter what you run a detector in, there's trade-offs. So you can hunt a site multiple times depending on what your mission is and what's in the site and how it's laid out. See, we don't know. We can't see under the ground with our eyes. Okay, so you're going to see these detectors like the DS2, like the fast program, sensitive FT, sensitive run a 40 max for default. Okay, you're going to see the Equinox 800. And I'd say the 900, even though I haven't used it, okay, it runs a part 2, field 2. Okay, well, those are actually better on lower conductors. The problem is they can be too good. What do I mean by that? Like the gentleman that lost the ring, I suggested that he go out and look for it for a while, you know, a few trips using the coin program. What happens running part 2 on an Equinox, and what can happen to you running 40 max frequency on a DS2, is small fall up here, even over a gold ring here. Say the gold ring only reads, it's not, you know, it's like a nickel signal, or maybe lower than a nickel signal for ID. But what happens is when you come across it with a higher weighted or higher running frequency, it sees that fall. So when you come across it, it makes the gold ring down here, it can make the gold ring read lower. It may make it read lower than what you would suspect the gold ring to be reading. If you change programs and you went to part 1 on the Equinox 800, 900, or the all-terrain general on the Manicore, okay? If you swept over that same scenario, the fall would not be seen as well. And this gold ring would have a higher level in the meter. You might not even see this gold ring running, say, a field 2 on a Equinox or it would be a very short signal with a quick ramp up, and it's like you just don't pay no attention to it. So looking for gold rings, higher frequency on these multi-frequency detectors is not always the smartest thing to do, okay? Especially where there's bits of foil, ultra small pieces of can slaw. Okay, camera back on. Now, this coil, you know, the deeper this target gets down here, let's say you get a target with a Manicore, Equinox, or a Deus 2, and it starts getting down to the 9-inch depth levels. Well, at the 9-inch depth levels, you can't have the masking in these areas up here can't be happening generally. Remember, a masker closer to the coil affects it more. Okay, so a masker can be down closer to target level and have less of an effect on it versus the masker being up closer to the coil. So if you dig a 9-inch deep dime with a Legend, a Manicore, or a Deus 2, or an Equinox, you dig a 9-inch deep silver coin, odds are there's nothing up here, okay? Odds are. No maskers, or you would have never heard it. Now, could there be something down here around this dime? Yes, certainly. You'll see people talk about, oh, they're in sights, it has a lot of iron. Well, yes, you could have iron that exists down here at target level. And yes, you could have iron that exists up here closer to the coil. But if you detect a deeper relic with a metal detector with an 11-inch coil, chances are, you know, there's nothing up here. If you hoist out that silver dime down here with that detector, you look in that plug right there and you sift it, you probably ain't going to find much, okay? You're not going to find a half of a nail. You're not going to find a pull tab. You're probably not going to find a ball of foil. All right, camera back on. You see these two lines that I've drew here? Okay. Let's put us a line up here to simulate our coil. As far as you detecting a target with some of these multi-frequency detectors, what's going to happen is this represents depth, okay? So you're going to find out, you're going to detect targets that are out of line from underneath the center of the coil. The shallower setups can have more deviation from where you're getting detection to the actual physical center of the coil. As the target gets deeper, that error will be reduced. Okay? So on a 3-inch deep target, you could have more error between spot of detection and where the target actually is on the coil. You get to 5 inches, it gets less. 6 inches, it gets less. All the way down. It's like the 9-inch part. Remember what I just said about a 9-inch deep silver dime with an 11-inch coil? You're not going to get any. There's not going to be anything up here, even outside of this coil to a degree. Outside of the perimeter of the coil, that's going to be a masker. Remember, that coil, if I draw this line right here and say that represents an 11-inch coil, well, when that coil is on the surface of the ground, something out here, a nail out here outside of the coil, a piece of modern trash outside of the coil is affecting that coil. So you just can't have, for an example, an 11-inch hole for that coil to find this 9-inch dime. You need much more than that. Okay? Now, how much more? Well, I can't say exactly, but you know, I've looked at this, and it's you know, it's more than what you think. You know, and when you look at somebody doing shallower tests, maybe you might not really get the true blue picture of what's really happening or what could happen. Okay, target ID. Lower conductors around iron using higher frequency generally gives more accurate ID. Lower frequency around nails, higher conductors, can give more accurate ID. Yet, the target may be detected in a more crippled position with the higher frequency, yet ID an error. If that makes any sense. So for select digging, lower frequency could yield a better ID versus higher frequency. But that same target could be positioned where you can hear it with a higher frequency, ID an error, and you can't hear it with lower frequency. The orientation of the iron could also be a factor, where higher frequency fails, lower frequency passes, but ID could still be an error. Okay, machines like the Equinox series, Manicure, they have a horseshoe button on them. Well, that horseshoe button can be handy. Well, the DS2's got one on it too, but it's not called a horseshoe. It's a ground balance button on the remote. Now, you can do this with the W6 Master, but it's hard to get to. Okay, what does it do using those buttons? What can they do for you? Here's what they can do for you. High conductive coins in a site can be masked by lower conductive trash, dragging their ID down. Silver dime could read like a zinc penny. So out in the wild, let's say you're running an Equinox or a DS2 or a Manicure, and you've got your disc set up, and you're allowing zinc and penny ranging higher for your conductivity levels. So you're out in a site, you sweep, you've got a zinc and penny ID in the window. Remember though, you've got everything else below it notched. So you get that zinc and penny ID and you're like, oh, a zinc and penny. Well, what you can do is you can hit the horseshoe button. You can hit the ground balance button on the DS2. I'm not sure what the legend has on this, okay? Made by Nocta. When you hit that button, what you're going to be watching for is, do you hear any iron tone? Or, when you move the coil slightly, do you see an ID shift? Do you hear a low tone? If you do, then that would give you, the user, a clue as to not believe the ID of that target, meaning that target could read higher once it's zoomed. So you're taking a chance. Now, can we tell how much higher the conductivity of the target down there has? No. But we can place good odds that target, that 85 reading target, say on a DS2 or a 19, I believe, or 20 on an Equinox 800. If we shift that coil and we hear that low tone or we see that ID plummet, that would be our signal. Uh-oh, let's dig this. That's probably not a zinc and penny. It could be a copper penny. It could be a silver dime, a clad dime. We don't know. Sensitivity on your metal detector. You ever notice your car stereo? You can turn it wide open, can't you? How's it sound? Well, metal detectors are the same way. You probably should never run one at max. All the models that I've owned and run, I didn't see anything gained. Actually, I've seen more lost than gained. Okay. A metal detector's got 30 levels of sensitivity. You know, you're probably not going to ever run it over 27 or 8. You're never going to be at 29 or 30, chances are. Some new beginners may get the machine and say, oh, well, I'll just max this thing out and that'll be as deep as she goes. I hear everything. Well, you better be thinking again about that. EMI. This is interference caused by different electrical sources. It can even be a thunderstorm off in a distance. Aircraft. Lots of different things. Light wires. Sometimes you will get audible warning if you've got interference. But just because you don't hear any audible warning that you've got interference don't mean you don't have any. I've seen this. I've seen this doing air tests on what I would deem crippled scenarios and be sweeping. And the signal gets extremely weak. Sometimes I've seen it disappear. Do a noise cancel, do the same sweeps, machine recovers. I start hearing the target. There are people out there that has missed some target. Now remember, the more critical the detecting scenario, meaning the detector's being pushed to its limits, this is where EMI really shows up. A 4-inch deep dive with an Equinox, EMI is probably not going to keep you from hearing that target generally, okay? All right. All the multi-frequency machines that's been released in the United States, so far, there's not one released. I don't think you can run one mode and walk into a site, even looking for high conductive coins, and necessarily locate all of them that detector's capable of, okay? Now some modes are better than others, meaning you would get maybe a higher percentage generally, but there's not one mode or one set of settings on that detector that will go in and bring out the whole haul, okay? So you could be successful as a new detectorist. You could buy a detector and go out and find several coins, and you could get it in your head, well, this is the real deal, and oh, I clean this side out, I'll go to the next one. Well, you might not have got everything. Coil size. Smaller coils require patience. They do have their place. Probably smart to take them into more polluted areas versus cleaner, versus a bigger coil. Even though a small coil could, in a cleaner area, strike something that a stock size coil could struggle on or not hit, it's possible. Alright, for you beginners out there, iron. Iron in the ground will behave a lot of times different than it behaves on top of the ground. The same iron, you could go out and dig some iron. You could sweep over it and hear how it sounds. Remove that iron, put it on a piece of styrofoam and sweep it, and it behaves different, sound different. Alright? The manicure users, same goes for that one. I'll give you a quick example. I had a horseshoe in the ground the other day, half a horseshoe, and I'm looking at it on that meter, okay? I eventually removed it. On top of styrofoam, I could never get that horseshoe to give anywhere. I looked at it from every angle, and I got to see how it was oriented in the ground because I seen the very top of it sticking up. I could not get a tray screen to duplicate, okay? Elevated above the ground. Alright, this is going to conclude the video. So, every time a new machine comes out, and let's say it's a manufacturer's supposed flagship, a user buys that's experienced. What they'll be doing likely is just like what I do. They'll be looking at the different programs, and they will be doing some of their own testing. They'll read the manual, and they will start to draw conclusions about iron performance, lower conductor, high conductor performance, modern trash performance. Then they'll take it to the field and they'll start using it. They'll probably read other people's comments. You know, this is sort of a team effort when one of these detectors comes out. There's data shared, and that speeds up the learning curve for everybody. Okay? Well, that's gonna do it. I hope you enjoyed.